All right, here we're in 1-6, locating points on a coordinate plane. And we are, I'll go down here to lesson goals, finding a point on a directed line segment on a coordinate plane that is a given fractional distance from an initial point. This is going to be very similar to 1-5 in that it's going to be a fraction of a distance from a point, but instead of on a line segment, you're going to be going in the coordinate plane, okay? So here's what we're going to be using. We're going to be using this key concept, and this key concept is so big that actually this entire statement is copied in your notes. So it is in your notes, word for word, that the coordinates of a point on a line segment that is AB, that's your fraction, of the distance from an initial endpoint to a terminal endpoint are given by that equation right here, where AB is the fraction of the distance if B does not equal 0. Okay. So what I want you to see before I move on is that they've given you some letters that are important and some letters that are not important. So right here, this A and this C, not important. They could be any letter. They will give you the letters D, the letters A, the letters B, the letters C, the letters whatever. They don't matter. What does matter is that they've told you that it's an initial endpoint and a terminal endpoint. That means beginning and an end. Or they'll use the words from and to. Okay? Now, secondly, they've given us an equation. I'm going to go copy that equation. And I'm going to go move it down here. We're going to see how to use that. Let's go use it down here. So they tell us that we need to find C on segment AB. That is 3/4 of the distance from A to B. So I told you they would use from and to. That means that this A is our initial and B is our terminal. That means, let's see, this A is our beginning, B is our end. And if we were to draw a line somewhere about halfway between it, and then another half between those, now if I highlighted 3/4 of those, 1, 2, 3 of those, this point right here, that's probably about C right there. Because that is 3/4 of the way from A to B. We've driven 3/4 of the way along that line, if that makes sense. Now, it looks like that point, if I were to look there, is not right on an actual intersection. So it's probably going to be a decimal point. So that'll be interesting. So we're going to go ahead and see what it looks like to plug in values for that. So as we go, they're going to tell us first we need to identify those endpoints. So we find the initial and those terminal endpoints. Our initial is going to be those x1 and y1. And our terminal will be the x2 and y2. And here they are. I like to actually go right into there and write it on them. So I go x1, y1, x2, y2, right over them. There we go. Now, I take the equation itself and I rewrite it. That's kind of a mess there. So I'm going to show you how I do it myself up here. Sometimes I like what they do for us in McGraw-Hill. Sometimes I feel like they just make a mess. So let's come up here. So if we've got x1 here and y1 here, and we've got, let's see, x2 and y2 is going to be 6 and 8. I'm going to rewrite this right here is our x coordinate, and this right here is going to be the y coordinate of point C. See that? That's what that little comma right in the middle is telling us, is that we're looking at two different equations. So let's look at just the x coordinate. So if we've got x1 plus a over b times x2 minus x1, let's fill in for that. So x1 is -7, and a over b is going to be 3/4, right? That is our a over b. So that's 3/4 times, let's see, x2 is 8 minus, and our x1 is, again, -7. Now, whenever you have a negative, I always encourage you to put that in parentheses just in case. There we go. And now let's work our way down on that one. -7 plus 3/4, and let's go inside the parentheses. 8 minus -7 is the same thing as 8 plus 7. Then I'm going to go -7 plus 3/4 is going to be 15. All right. And then we end up with -7 plus, that, do you guys remember fractions? It's been a hot second since we've done fractions, hasn't it? Well, if you remember this, 3/4, I'm going to zoom in a bit. You can do, I'm going to make my lead a little bit smaller too. There we go. 3/4 times 15/1. That's the same thing. Okay. And we'll make that a bit smaller there and go, that's -7 plus, and we'll multiply across the top. 3 times 15 is going to be 45. And multiply across the bottom, which is 4 times 1. So 45/4. Okay. And then if we're going to add those together, we need to have like denominators. So that would be somehow I turned back to blue. Oops. -28/4 is the same thing as that -7. Plus 45/4. And let's see there, we got 15, 16, 17. 17/4. Which is 4.25. There we go. And I can go ahead and shrink some of this down so that I've got room for all the rest of it. And we'll go ahead and put that over there. There we go. So my x coordinate is going to be at 4.25. I'm not sure if that quite made sense. So I might have done something wrong. Go too far. 2.75. So I did my math wrong. 2.75. Right in here. 2.75. Okay. Next up is doing the y's. So let's go ahead and do the x, the y. Oh, now I'm too skinny. y1 plus a over b, and y2 minus y1. And now we're going to go black, and we start filling that in. So we get -5 plus 3/4, and we're going to go with 8 minus -5. Okay, now, instead of working it all the way down, which you certainly can do, I'm not going to get mad at you for working it down. I'm going to go ahead and also recommend you start using your calculator so you don't make Mrs. Cruz size mistakes. I'm going to grab this out of the way. You can plug this in just as it is. As long as you have your parentheses in the right place, it's all correct. We're going to plug it in just like that. So plus 3 divided by 4, because 3/4 is the same thing as 3 divided by 4, times 8 minus a negative 5. There we go. See, my equation right there is exactly what I've got written down, and that would be 4.75. And if we want to double check our x's, we can go ahead and write that one in as well. Plus 3 divided by 4, 8 minus negative 7. Oh, I did write something in wrong. Negative 5? No. 7, 6. I put in... Somebody was yelling at me from the back, weren't they? Here it is. This should have been a 6. 6. There we go. So my math wasn't wrong. It was my filling in. There we go. So C is going to be 2.75 and 4.75. And the good thing is that right away I knew that this was wrong because it didn't pass the common sense check. It wasn't in the right spot. I came up with a 4.25, which would have put it up here in the wrong spot. So please double check your work. Make sure it's in a good common sense spot. There we go. Okay. Now, they ask you, what are the coordinates of a point that is 3/4 the distance from B to A? So, just asking the question, does it change up if your initial is B? And it absolutely does, because now, all of a sudden, you're moving from here to here, and you would end up at this spot. Okay, now go ahead and try the practice on this one. Find P on QR that is 1/6 the distance from Q to R. Go ahead and pause me and check. Okay, now did you find that it was at -1, -3? I hope so. All right, now we're going to do the section formula. It can be used to locate a point that partitions a directed line segment on the coordinate plane. So what this does is when you're finding C on AB such that the ratio of A to C, C to B is 1:2. So now instead of having a fraction, they're giving you the ratio, okay? So if they've given you the ratio, how do we do that? And now they've given you this big equation. And let me tell you, this equation works just fine. And if you like this, this is great. And we'll go ahead and do this equation in just a second. I'll show you how it works. But what I want to show you is that if you don't want to learn a new equation, you don't have to. Because if you want from A to C, C to B, 1:2, what they're saying is that there's somewhere in here, there's going to be a point C that when you put it in there, it's going to be 1 part over here and 2 parts over here. Well, that means the fractional distance of A is going to be 1/3. It's going to be 1/1 plus 2, if that makes sense. 1/3. So if you want to change a ratio to a fraction, you take A to B, you go A over A plus B. And then all you have to do is go back up here and use the equation we just did. Totally fine. You can stick to just one equation. You're all good to go. Okay. But if you want to try this equation, where we've got m's and n's now, totally fine. We could try this. And it's a little different and maybe not so hard. It does some funky things. It's now got a ratio of m to n, L, M, N. So it's got alphabetically, the m comes first and then the n. And then it does this funky thing. It does the n's go across here and the m's go across here. It's still adding, so that's not a big deal. I mean, on the bottom, they just add together. But the n multiplies with x1 and the m multiplies with x2. So, ooh, how much stuff did I want to go ahead and do? There we go. There we go. So this multiplies with these guys, and this multiplies with these guys in the equation, if that makes sense. So let's go try it. I'll go ahead and erase all this stuff off here. Delete. I'll go grab this and copy, bring it down here. So we've got it. And then we're going to go ahead and write that this is m, this is n, this is x1 and y1. This is x2 and y2. And I have to double check because you have to make sure you're going in the right direction. Because remember, if you're going from m to n, you need to make sure that A is on the m side, B is on the n side. There we go. A to B, m to n. Okay. All right, so if we fill this in, n is going to be the number 2 times x1, which is -5, plus m, which is a 1, times x2, which is a 6, all over 1 plus 2, which is 3. And if I were to multiply that, that's -10 plus 6 all over 3. And -10 plus 6 is -4 over 3. Did I do that right, guys? Are we feeling good about that? I think I'm okay with that. -4/3. Okay. Now, second one. N times y1 is -2 plus m1 times, let's see, y2, 2, all over 3. And then that means -4 plus 2 all over 3. It's going to be -2 over 3. So our coordinate, C, is going to equal -4/3, -2/3. So let's go check to see how we did. -4/3, -2/3. That's actually not so bad. You might like that equation better than the first one. So you could try and break your fraction into a ratio if you kind of like your ratios better. Maybe try that instead. Got a couple options. Okay. So go ahead and practice this one. Try this, pause me. Go ahead. Did you get B? Okay. Next one, I believe this one, you're going to go ahead and try this in part 2.